Hello and welcome to a new episode. I'm Anup Matthew, and today's episode is on the background of the recent ASER survey on school mathematics studies and NCRT annual reports. So, what we can observe from these reports is that in third standard students, they are struggling to cope up with mathematics studies. One simple survey question that has been given is a two-digit subtraction for third standard students. Unfortunately, when we take into account of the pan-India, hardly one-fourth of the students could be able to solve two-digit subtraction. Rest 75%, they wouldn't be able to find an exact answer. More specifically, when we break down these numbers in terms of state-wise picture, we can find that 10 states are below than the national average. States like Madhya Pradesh, Rajasthan, Chhattisgarh, Meghalaya, Jharkhand, Gujarat, Tamil Nadu, Karnataka, Uttar Pradesh and Maharashtra. That's below the national average, and rest are above the national average, still not satisfactory. Only one state, that's Manipur, could be able to cross the 50% mark, and northeast states did a better job in terms of numbers. Smaller states like Kerala, Punjab, Himachal Pradesh, Haryana, Sikkim did better when compared to rest of the states. Maybe the reason why better numbers are delivered by smaller states, especially northeastern states, maybe because of the penetration of education may be less, or in other words, those who have the access of education may belongs to the privileged class only. So the quality has been maintained. Rest of the students, they even didn't get an opportunity to go to the school itself. That may be the reason. I'm not sure about it. That's in the case of Northeast. Along with that, we have to go through another set of numbers. That's a percentage of children taking some or another form of paid classes outside the school, or in other words, paid tuitions they have taken. You can find that states like Odisha, Jharkhand, West Bengal, some northeastern states, Punjab, Uttar Pradesh, all those states, students are taking more than 30 or 40% of the students are undergoing paid tuitions, but still the numbers are not good. So why we are concerned much about this number? That's a question. Mainly because of the fact that we can find that in the past one decade, the penetration of education in India, even into the rural area, is on a very appreciable levels. Even the penetration of English medium schools in the interiors of rural India, that itself is in a very formidable numbers. But still, having this much education facilities, including private schools, what happened to the quality of education, especially to mathematics? That's an alarming question that sustains here. At this scenario only, we are trying to analyze the scenario as well as where we have done some fault on deteriorating the quality of mathematics education. Before we proceed further, many are still not convinced about the importance of mathematics in our life. Some are impressed with the skills of mathematics, maybe because of the fact that they want to send their kids, or they want to go themselves for some analytical arena, something like economics or engineering or statistics. Apart from that, where exactly mathematics has been positioned in a common man's life, that important fact, we as an academic community fail to convince the other stakeholders of education institutions. There only the first issue starts. The question is very simple: why we should learn mathematics, or why we should acquire skills in mathematics. First and foremost thing, usually we used to tell that mathematics is the language of science. That definition itself is somewhat horrible in nature. Because if a student feel that, if a student say, okay, I'm not going for any of these analytical subject, or I'm not going to learn science, I want to go and learn history or humanity subject, then you will say, why should I learn mathematics, since that's the language of science? So as a teacher or an academic fraternity, you should tell that mathematics is not the language of science, instead that's the language of life. Anything and everything you can quantify and translate into mathematical impressions, expressions and equations. That makes a common man's life easier than brooding over some set of data. So the definition itself we have to change a little, so that the ambiguity in purpose of learning mathematics can be eliminated. Second thing is, why or what's the actual purpose of teaching mathematics in schools, especially that as a mandatory subject? When I ask the same question to many teachers in schools or in the colleges, they have a answer something like, okay, mathematics, having mathematics skills, I can go to the shop, I can purchase something, or if I want to do some day-to-day transactions, mathematics is needed. Obviously, it's not just the usage of mathematics confined to go and transaction that happen in the economics or in the shops, but mathematics as a life skill we have to teach and learn. For example, the ultimate skills that a student need to acquire by learning mathematics is, the first one is the critical thinking. Whatever may be the data, you should be able to automatically convert that to some mathematical expressions, or you should be able to quantify it and analyze it. For example, the general expression is diesel cars are economical than petrol cars. But if you are a mathematics student or know the skills of mathematics, in that case, you should be able to find the total ownership cost that incur in the next 10 years by a petrol car or a diesel car. In which all case, he can analyze. First thing is the initial investment. To say diesel cars is almost 1 to 1.5 lakhs costlier than petrol car. There still you have to factor in the interest for 1.5 lakhs. Along with that, per kilometer maintenance, extra maintenance incur for diesel cars. All those things when we factor in, and the cost of ownership for the next 10 years, the particular student need to jot it down and have a clear-cut comparison. Think critically. Then finally, he may come to a conclusion that petrol cars are more economical than diesel car. So this is critical thinking. With numbers only, we can critically analyze any facts and come to a conclusion. This is the first and foremost thing the student should learn through mathematics. Other one is the optimization. With available resource, how well we can optimize. Must have a fair know-how and handling skills there with permutations and combination. Without that, optimization may be a bit difficult. At least that permutations or combinations are needed apart from any higher order mathematical skills. Other skills are logical and sequential skills. We know that to illustrate this, we can take a small example. If I'm giving the student a small word problem, Ramu went to the shop and bought 5 mangoes for 10 rupee each and 2 coconut for 20 rupee each. What's the total cost or total amount Ramu need to pay to the shopkeeper? Assume that if the student is just writing 5 into 10, 50, and 20 into 2, 40, 50 plus 40, it's 90 rupee. If a student write the particular thing 90 rupee, ma'am or teacher, 90 rupee, Ramu need to give to the shopkeeper. If the student write it as on a sheet paper and show that to the teacher, will any teacher accept that answer? The answer is correct, right? No. Every teacher will tell that you go and write the statements or the steps to find that particular answer. Why the teacher is telling so? Is that to improve the language skills? Obviously not. That particular problem has 2 sub-problems. Cost of mango, cost of coconut. So by writing the steps, student is trying to break a bigger problem that contains 2 sub-problems into 2 sub-problems itself or smaller problems. Student is trying to break up a bigger problems into 2 sub-problems or smaller problems and find solution for these 2 smaller problems. And towards second, student is integrating solutions for smaller problems into a bigger solution for a bigger problem. While write the steps for finding the total cost, student will write, or student will try to find the total cost of mango to be given to the shopkeeper and total cost of coconuts. After that, he will add it together. This is what happens. The skill of breaking down a bigger problem into smaller problems, then finding solution for smaller problems as a smaller solution. Towards the end, integrate the smaller solution as a bigger solution to a bigger problem. That's the necessary life skill we have to teach to our students. This is what basically mathematics does. This is the main reason why computer science has been taught in the schools also. The primary intention is not to make all the students as programmers or coders or to push them to the software field. No, exactly not. Ask them to learn programming just because to have a skill to break down the problems into smaller problems and find a solution for that. This is what exactly does they are in programming or writing algorithms for a specific task. One interesting fact you might have observed during the school time is till 2nd standard or 1st standard or even till 3rd standard, 90% of the students score 90% of the marks in mathematics. But after that, what happens? All the parents, teachers, students, everyone start to pray when the student reaches 8th standard or 9th standard. At least you should pass with bare minimum marks. What happened there? How many of you think that your kid's intellectual levels went down? Or do you think your kid born intelligent but education ruined him? Exactly that happened. This case is not isolated. Learning mathematics and applying mathematics is one of the easiest skill anyone can acquire. That's why in the lower classes, students score better marks in mathematics than any other subjects. Unfortunately, when they move up, the mode of mathematics transaction make them sick or suppress the natural skills with numbers. So ultimately, who is responsible for the deterioration in mathematics skills? It's no one other than the entire society around them and each and everyone that directly or indirectly taking part in the process called education. In order to understand or in order to find the solution for make the mathematics teaching learning process better, first we have to identify what are the reasons for the deterioration of mathematics teaching learning process, especially in India. Or in other words, why mathematics looks very difficult for majority of the students. The primemost reason is the fear. Who instills the fear? Everyone, including the parents, teachers, and the entire society around them. Some learning apps, they say that mathematics is a very difficult subject. Without mathematics, you can't live. Mathematics can't be managed by common man. So please join with us. We will make you Albert Einstein and Ramanujan. Because of the fear of missing out, FOMO factor, majority of the parents fall prey into it and they pay huge lump sum of money. Directly or indirectly, they are admitting that mathematics is a ghost that may horrify their kid at one point or another. The parents' fear obviously diffuse into their kids also. So in subconscious itself, we are giving them an impression that mathematics is a ghost. Normal man can't manage that ghost. There itself, the fear towards mathematics starts. That's the first reason. Second reason is some kids, they have attention difficulties. In the lower classes, the students with attention difficulties, they perform well in mathematics because the problems are small, and when compared to any of the language or other subjects which are somewhat subjective in nature, mathematics needs lesser span of attention. So in the lower classes, till first standard or second standard, the students perform better in mathematics than any other subjects because they don't want any longer span of attention. But as the grade progresses, mathematics demands longer span of attention in terms of them to solve longer derivations. That will become much worse when they enter into the higher secondary classes or high school classes. Not just mathematics. Subjects that rigorously apply mathematics like physics or chemistry, that also needs this kind of longer span of attention. The students with the lesser span of attention, obviously they struggle to cope with mathematics. Or in other words, take into a positive sense. If you can instill love towards mathematics to your kids till the end, though your student suffers with attention deficiency, he can improve that. As a parent or a teacher, we have to take it in that way. The third reason is obviously mathematics demands continuous learning. The concepts are generally continuous. If a student doesn't know the concepts of first standard, normally in second standard he will suffer. He can't able to manage the problems over there. This continues. If you skip some sort of topics in second standard or in third standard, he may not able to perform well in fourth standard. So this one is almost like a chain reaction. Once the kids start to suffer, he gave up his struggles with mathematics. He obviously concludes that mathematics is not my cup of tea. I give up. Whether the kids are responsible for that? Obviously not. If some teacher, if she or he skips some topics or takes some topics in a lethargic way, sometimes that topic may redundantly comes to other classes also. Whenever that topic comes, the student may struggle. The fourth reason is the teaching community failed to convince the students about the purpose of learning. The rule of thumb that every teacher needs to follow in teaching is teacher should teach for a purpose. That purpose should be noble. And towards the end of the course, towards the end of the semester or year, the student should say, I have learned for a purpose. Whenever teaching for a purpose converts to learning for a purpose, there happens a fruitful transaction. Unfortunately, majority of the teachers forget this important fact. That's a crux of teaching. This leads to an aversion towards that particular subject or concept. If you are a teacher and if you can be able to convince the student about the purpose of learning a particular concept in mathematics, I assure you, that particular student will not forget that concept. Instead of that, if a teacher is teaching a particular concept just for name's sake, or just like the way that given in the textbook, just reading or just iterating that in the blackboard, that will not serve the purpose. End of the year, student will ask, why I have learned all these things. Even in many PTA meetings during my college itself, when the parents come, some parents ask the very same question. We also learned a lot of things there in algebra, trigonometry, all those things. I don't know where I have to apply it. This question arises. This question is an indicator of a teacher's failure. Every teacher should research on every concept where that particular concept can be applied in their life. Then only teaching will be fruitful and complete. One another reason why the mathematics become a difficult subject and it will not serve the purpose is the present day curriculum. Majority of the present day curriculum and the teacher resources that mainly disappoints both the talented minority as well as the non-participating majority. In the mathematics classroom, you can find two kinds of people. One is the talented minority. They are fond of mathematics, very much fond of mathematics. They will do all the problems within a fraction of a second or minute. They feel that that class transaction is below their standards. Other class of people, next category of people, they are the non-participating majority. They feel that this mathematics content is a hard nut to crack. Mechanically, we can write and learn something. That's it. End of the day, what happens? The non-participating majority may learn something, but not for good. The talented minority, their standards in mathematics will be dragged down to some extent. So towards the end of the session, what's the need of teaching such kind of mathematics classes? That's a point to ponder. Seventh point is the lack of teacher preparation. That you can read along with the previous point. Like teacher need to prepare a lot before you go to the mathematics. Or teachers sometimes used to get deceived with mathematics, especially in the lower classes. Because at least till 7th or 8th standard, all the concepts there in the mathematics are very well known to everyone. Addition, subtraction, basic algebra, and basic geometry, so and so on. So how good is the text or textbook or the teaching resource itself? Teacher always have an inbuilt feeling that, oh, that content I know. I'm teaching that for quite a long time. Nothing new in that. Write two numbers and ask them to add. That's all. So teacher will not take sufficient efforts to prepare for the class on how well he or she can present that particular concept in front of her student in an appealing way. Moreover, teacher need to invest time on how to implement that particular concept by the student in his or her real life. Sometimes need rigorous research for that. So teacher preparation is one another main thing why students as well as the entire mathematics stakeholders suffers. The seventh problem is the compartmentalization issues. Compartmentalization means teachers in pre-primary, they are considered as a separate compartment, primary classes separate compartment, high school separate compartment, higher secondary separate compartment, college education separate compartment. Unfortunately, there is not that much communication among these people. If they have a proper communication between them, at least pre-primary teachers will get a better know-how about where the student is heading to and what's the basic purpose of learning certain concepts that in the lower classes itself. For example, in the primary classes, when we introduce area of irregular shape, to say something like a leaf, I have seen in a certain curriculum that find the area of a leaf by using a square or grid paper. Okay, what are the grids that covered by that leaf fully, that will be taken as 1 square unit, and more than half or half that's covered by the leaf can be taken as also 1. So less than half can be avoided or neglected and just add it. This way we can get area of that irregular shape called leaf by dividing that leaf into a number of squares and towards the end add up together to get the total area. Two things we have to take into consideration. That area is not the exact area, that's an approximation. So heuristics method has been applied. So that's one deviation from mathematics. Teachers, majority of the teachers in schools, they are reluctant to accept approximate numbers. They always look for exact numbers. Fortunately or unfortunately, everyone should understand that in real life, mathematics itself is approximation. Infinite number series are there, just like pi. Just imagine, when we approximate pi to 3.14, in the case of a spaceship or in big structures, what effect that will make. So practically we take approximate numbers instead of exact numbers. Teacher need to accept it. So in this case, it's an approximation that's very well accepted. Where this particular concept is being extended. In the high school classes and the higher secondary classes, one thing called calculus is there. Integration is the part of that. In integration, basically exactly what we are doing to say if a function f of x, integral x1 to x2 f of x dx. What exactly it is? Area under that particular function f of x dx is the integral of x1 to x2 f of x dx. What exactly we are doing? We are taking a small area called dx, that infinitesimally small area. We are dividing the entire area with the dx area from x1 to x2, and by integrating it from x1 to x2 or f of x, we are adding it together and get the answer. The same concept we have applied there in the case of finding the area of a leaf itself. So when a primary teacher takes mathematics class in the primary classes, the same concept in some way or another that has been in an elevated mode, that's applied there in the higher class also. When a teacher gets a comprehensive idea about this thing, the issues that pertains with compartmentalization to a very great extent can be avoided. Teacher should have a hawk-eye view on the entire topics. Mathematics should not be taught in isolation. Mathematics teacher should understand that mathematics is not a standalone subject. Mathematics can sustain only with other knowledge like engineering, science, or economics, or commerce. Another issue is with the curriculum acceleration. Teachers may not be prepared for that. Curriculum acceleration means, for example, when I was doing my graduation, the concept there in my graduation at that point of time, that concept now has been integrated to the 12th standard of almost all the state board schools now. Similarly, what all concepts I have learned in my post-graduation levels, now that has been moved down to the graduation level. This is curriculum acceleration. Some of the concepts, if a teacher, if she's a bit experienced, if she have learned that in the 12th standard, same thing she could able to find that in the upper primary classes or maybe in high school. That's curriculum acceleration. But unfortunately, she may not be prepared to teach that kind of concepts there to the lower primary students or upper primary students. So need rigorous practice and training to accommodate these kind of skills. That's the one reason why mathematics teaching has become a flop in our schools. The 11th reason is nothing but mathematics teachers majority of the time teach mathematics just like a subject, not as a skill. We should understand that mathematics is a skill, just like a bicycle riding. The more you practice, the skill will be more and you will be well versed in that. You can find that while you ride bicycle initially, we will take a lot of efforts. We will stare like this and straight like this and ride with a lot of caution. But after we practice that for 5 or 6 days, what happened? Some kids, they may lift the front wheel and go in the single wheel itself, right? So they have mastered that skill. Similarly, in mathematics also, teachers should give some opportunity for the students to master this particular skill called mathematics. Teacher never try to prepare a lesson plan or never try to teach mathematics like she is trying to teach English or history. That's one of the greatest traits. Mathematics teaching is entirely different from the way teach other subjects. Unfortunately, majority of the teachers forget that fact. It's a skill, it's not a subject. 12th problem is majority of the time, majority of the teachers, they forget the fact that mathematics is not about the knowledge transfer to the students. Instead, teacher is there to teach them the process to solve the problems. The process is important, not the concepts or the knowledge. One classic example of this is addition with carry. In first standard or second standard, we teach students without carry, addition without carry. For example, if you teach them 11 plus 22, and teachers will say, okay, add from the right side to left side. Okay, 1 plus 2 is 3 and another 1 plus 2 is 3. So you'll get as 33. And we'll give 101 problems also. Some students may not listen to this. They may start to solve the problem from left to right also. 1 plus 2, 3, 1 plus 2, 3. They also get the same answer. but they practice 101 problems with the same process of adding from left to right. That process they have assimilated to their heart and they have managed well. In the next grades, in the fourth standard or something like that, when you go with add with the carry, what happens? Teacher may say something like 27 plus 13. Some problem will give like that. The student, they have a practice of adding from left to right. He will get an answer of 310 instead of 40. Now what will happen? Now the teacher will take 101 efforts to make them correct. But that may not be an easy task. This particular problem happens in majority of the schools. Where exactly it starts? It starts in the lower grades. Teacher didn't take much efforts to make them correct. Teacher failed to identify the process that what the student was following. Instead, teacher just concentrated on the results. Teacher just checked the results. Okay, result is 33, it's good. But she didn't take enough efforts to identify in which way the student get that particular answer. Process was missing. So mathematics is nothing but process. We, as a mathematics teacher, we have to teach them process, not the content. As I told you earlier, mathematics is a skill, not just a subject. So whenever you want to master a skill, we need practice. In some schools, I have seen that some schools are homework-free schools. They boast in that way also. I have seen in many hoardings that homework-free schools. Good. Students will get more time to spend with their parents when they go home. It's good. But unfortunately, when it comes to mathematics, when you give some homework to do at home, that's a practice. If they practice well, that's good. So schools without homework, the students in that particular school sometimes may struggle to manage mathematics since they are not practicing. The last reason, that may be some of the most important one, that's the attitude of the teachers. When I went for a teacher training, I just asked one question. How many of you teach non-analytical subjects like history or geography or language or anything like that? A few of them raised their hands. I just asked one question. How many of you have chosen your first graduation as history or English or whatever may be the subject of your concern, just because of the fact that you love that subject? Among that, 90% of the teachers replied, no. We have chosen this particular subject called English or history just because we want to avoid mathematics from our life. By 12th standard itself, we fed up with mathematics. So somehow we want to escape. Not that we love Hindi, we love English, we love humanities. We have chosen that subject as the first graduation. Instead, we want to get rid of mathematics. Now you just imagine what kind of damage that particular teacher's teacher did to their students. That extent of aversion has been created. More interestingly, in some schools, especially in the lower classes, some systems called mother teacher systems are there. That particular teacher may be specialized in English or history or something like that. But she had the responsibility of managing mathematics also in that particular school for that particular grade. Maybe in LKG, UKG or first standard or second standard, since she is the mother teacher. That will cause enough or damage to that students. So at least mathematics, that should be spun off and managed by or taught by the teachers of that particular specialization. Now you may think the teachers there in the entrance coaching centers or that kind of people, they may be very good in mathematics. Fortunately, unfortunately, what we found is those teachers are not good in mathematics. Instead, they are good with some magic tricks. Ready-made equation, they throw with some ready-made equation, apply that equation. That's not mathematics. Mathematics is a skill, and a mathematics teacher should instill the student to dig in to find a solution for a particular problem. Instead, apply the numbers to a given equation. That's not mathematics. Anyone can do that. Never classify such teachers as good mathematics teachers. Instead, the teacher should instill some sort of interest to the student to go for at least some trial and error methods to solve a particular problem. Instill the interest to start right from the beginning to derive a solution for a particular problem. But instead of that, when we move up the ladder, especially in the high secondary classes, what exactly happened? In the physics or mathematics or whatever it is, we are looking for ready-made equations. That's not going to benefit for anyone. That's why, though students, they scores better grades, better ranks in entrance, they struggle there in the higher education, whether that in mathematics, higher education BSc, or in engineering or whatever it is. Ready-made magic formulas will not work good for anyone. That's not mathematics. Another reason is about the teaching resources. Teaching resources, the main teaching resource is the textbook. So the textbook mainly in majority of the schools, especially in private schools, they depends on private textbooks that are released by private publishers. Nothing wrong in that. But fortunately or unfortunately, among a lot of publishers, some publishers textbook they made just for namesake. They just take their academic team or someone is there or some ghostwriters, they take the content from NCRT and paraphrase it and give to you. Unfortunately, they are least bothered about the implementation part, whether that can be implemented everywhere or not, or in which way the transaction to take place in the classrooms. All those things matters a lot. Unfortunately, these kind of textbooks also makes a lot of damage to the students. So always try to choose textbooks which are of better quality. Make sure that that has been authored by veteran academicians and time tested and revised based on the field level feedbacks, etc., etc. Never choose textbooks based on the discount or commission or economy, because we are handling with a generation. Parents may not find it as a big issue to spend a couple of bucks for their students' education. So as a teacher, what we have to do is, its mathematics teaching is almost like inculcating some sort of culture to the students. Teach with a passion, teach it like a skill, and we should make some sort of habit to the students like think mathematically. Think mathematically means whenever they hear something, they should be able to translate that into equations. They should have a habit of quantifying the data. They should have a habit of translating a verbal problem into numbers. If you as a mathematics teacher can instill that skills to students, you will be a successful teacher. Encourage students to go for heuristic approach, approximation methods. For example, instead of giving a problem like if the length of the classroom is 50 meter and breadth of the classroom is 20 meter, find the area of the classroom. Instead of that, you ask the student to find the length of the classroom by inspection. Just look on to that, because already they have learned about the units and everything. So let them look and estimate it, the length and breadth. Then ask them to get the area. Sometimes students may say that it's 30, length is 30 instead of 50 and breadth is 15 instead of 30. Well and fine. After that, you show them what's the exact length and breadth, what's the error that they have caused. So that error, that delta, that will come down as days go by. Students should then understand towards what they are working to. Never discourage or make them fear about the errors or mistakes caused by approximation. Real life demands approximation, not exact values. So that's all for now. See you in the next episode. Till then, bye from Anup.